Now let's make a first circuit with the gate maker that we had. The first circuit will be a combinational circuit. So combinational logic is characterized by the fact that it has no memory. All calculation is done at the same time instant. So for example, a gate is already a simple combinational function. So zi is xi and yi. At the instant I calculate x and yi, getting zi at the same instant. So the output is at the same instant as the two inputs. If I now connect any number of gates together, I will get a combinational circuit because the final output is also calculated at the same instant. Notice that there's going to be no cycles in this diagram, otherwise that would give deadlock. So we will have an acyclic combination of gates calculating some kind of a function. So let's define a useful circuit called a full adder with this idea. So a full adder is the basic building block of an adding machine. It's able to do all kinds of additions with 1-bit numbers. So it takes 3 1-bit numbers, which can be either 0 or 1 each, and it calculates their sum as a 2-bit number. In fact, there's a sum bit and a carry bit together forming the 2-bit number. So we can go from 0 plus 0 plus 0, giving 0 and 0, or 1 plus 1 plus 1, giving sum 1 and carry 1, which makes 3. So this table here gives all the possibilities. So the full adder is an addition building block. We can build an n-bit adder by connecting n full adders. So here's the full adder as a 5-argument component. Notice that inside here we're going to call the functions AND G, OR G, and XOR G for each gate of the full adder. There's a total of 7 gates inside. We have 5 internal wires, 5 external wires, giving 10 wires in all. So each time we call full adder, we will make a new running instance of a full adder. So how many threads are running whenever we call full adder? Well, since we have 7 gates here, there will be 7 threads running. And if I build now an n-bit adder, let me show you how that works. By connecting full adders, each full adder does 1 digit, the x and the y input. It returns a z, and then we're connecting them together, like this, for example. We have the 2 n-bit numbers coming in, bit by bit. Each one of these is a full adder. There's a carry input and a carry output going to the next stage each time, like this. So we have n-bit adders, n 1-bit adders together making a n-bit adder. If we now have a 32-bit adder, let's say we build a 32-bit adder using full adders, how many threads does this thing have?